Hello and welcome. We're going to be talking about quadratic equations today. The main goals of today are graphing quadratic functions, as well as identifying and describing some characteristics about those quadratic functions that include the maximum, minimum values, the vertex, intercepts, axis of symmetry, and the direction of opening. So what is a quadratic function? Well, it's a type of polynomial function of degree 2, which means it has the highest exponent of 2. In this case, a cannot be equal to 0 because otherwise there would be no x squared. B and C, on the other hand, can be 0 or any other real number in this case. So we're going to assume that a, b, and c are constants with a not equal to 0, and they are part of the real number system. So this quadratic function has a parabolic shape, or a parabola, which is a conic section, meaning it's part of a cone. So if we looked at a cone, like an ice cream cone, and you cut it at certain angles, like a slice through it, that would be the shape of a parabola. The graph of a quadratic function is a parabola, which is symmetrical. It is U-shaped, and if a is greater than 0, it opens upwards, and if a is less than 0, it opens downwards. So, for instance, again, it looks like so. It either opens upwards or the smiley face, and again, that would be a. The value in front right here is greater than 0. And if it opens downwards, we know that a has to be negative, so it's going to be a negative value. So this is a is less than 0. Again, this will be negative value for a. So some characteristics of these are it has an axis of symmetry. This is a vertical line that passes through the vertex, which we'll talk about that, and divides the parabola into two mirror images. And the equation for that axis of symmetry is right here. So this is important to know and have. That axis of symmetry is this equation. So just to do a rough sketch here, if I have some sort of graph kind of looking like so, we have a parabola that looks like this. The axis of symmetry goes down the middle of it where it's perfectly symmetric on left and right. Obviously, I did not draw it perfectly, but this side should be mirror image to the right side. And where does it touch that axis of symmetry? Right here, that y value, and x value will be this vertex. So the vertex is this area right here. The axis of symmetry is this dashed line right there. Now, the vertex is the highest or the lowest point. So in this case, it'd be the lowest point. So it'd be a minimum value. And then depending on its orientation, like I said, it's going down or it's opening upwards so that it would have a minimum, hence the orientation. And this point can be found by using this axis of symmetry, whatever this x value is, and we're going to plug it back into the original formula. So you just take the y coordinate, or find the y coordinate by just substituting in this value into the original quadratic function equation. So let's go ahead and graph a parabola of the form y equals ax squared plus bx plus c. So it has 2x squared minus 16x plus 37. So the way we're going to do it is we're going to plot the vertex, the middle, and then we're going to do 2 points to the left and then 2 points to the right. And how to graph any equation ever in the history of mankind is by just making an xy table. So we're just going to find the middle, which is that formula of x equals negative b over 2a. And we're going to substitute those values in. Again, this value is a, the 2 is the a, the negative 16 is the b, and the c is this plus 37. If it wasn't in this order, you'd have to rearrange it in this form here. Y equals this, or 0 equals this, in that form. It has to be in that form in order to use this equation. The a is always in front of x squared, the b is always in front of the x, and the c is the constant. So just substituting in those values, our x is equal to the opposite of 16, negative 16, all over 2 times 2. Which, if you think about it, this turns into positive 16 divided by 4, which gives us x equals a positive 4. And that will be my middle value here for my vertex. So that's what I put in the middle. And then what I'm going to do is I'm just going to go down 1 and up 1. And then I'm going to go down 2 and up 2. So I'm putting these in the same color because since it's symmetric, if I plug in 3 or 5, they should be exactly the same value. If I plug in 2 or 6, they should be the exact same value because it's the same distance from the vertex. And again, these are symmetric. So let's go ahead and substitute in there. So first start by substitution. 2 times x squared minus 16 times that x, and then plus this 37, which will give me a value. So if I'm substituting in this 4 here, I should get that value is 5. So I get the point 4, 5. So go right 4 and up 5, and I'm going to place a dot. This is my vertex. Notice how A is positive, so it is going to open upwards from there. So this is the lowest point or the minimum value of this. So then all I have to do is copy and paste that using a TID4. It's actually really nice, or some of the other calculators very, very nice because you can just use a table feature, or you can just substitute in 3 again, or just type over that and then figure out what is that value, which you should get 7 for this case, which at 3, which is to the right 3 and up 7, is right there. The nice thing is this point matches over here because it's symmetric, so this also has to be 7. If I substitute 2 in for those, for both of those, let's just put all the other information, 2 squared minus 16 times 2 plus 37. This is in fact equal to 13, which makes this also 13. So at positive 2, I get a 13, and then over here, I also get a 13. Now, this is a smooth flowing curve. There is no rigidity or points, so it's kind of very curvy here. You don't want a V point. You want kind of a curvy, like a U, because it's U-shaped. So try to make it as curved as possible and just do your best. So now we're just going to state some characteristics about this. We're not going to graph it. We're just going to state a few things. So first off, we have this function, 2x squared plus 12x plus 19. We are asking, does it have a maximum or minimum value? Which, how do I know that? Well, we look at the a value. Again, a happens to be 2. So if a is greater than 0, then we have a minimum value. And the reason why is, again, the function will look like this. It will go up, and then this lowest point here will be that minimum value. So I would prefer and ask you to explain your reasoning, and if you don't on a test or quiz, you will absolutely get points docked off. You would have to like, oh, a is bigger than 0, or 2 is bigger than 0, just to explain it, and then you can show a graph as a way of drawing it, or just graph it if you like, and then you would state that there is a minimum. Now, where does it occur? Where is always going to be talking about the x value. Where is the x value? And then what, for the next question, would always be the y value. So when you see those words, where does this occur? Well, that is my x value. That is my independent variable. That is telling us where we're doing stuff, and then because of that, this y value depends on it. So what is that based off of where it's located? This is just really simple again. It's that x equals negative b over 2a, which again, just substituted in. We know that a is 2, b is 12, and c is 19, so plug those in. So we have the opposite of 12 all over 2 times a, which is also 2. So this ends up being a negative 3. So at x equals negative 3, by the way, x equals negative 3 is your axis of symmetry. And that is a line, a vertical line. So if I asked you for the axis of symmetry, you would have to say x equals negative 3. Not just negative 3. Negative 3 is an explaining marks, but we have to say that x equals negative 3 because that is a vertical line. Now, how do I find the last part? Well, that's pretty simple. Well, again, we substitute that value into the function. Well, it's g of x, so we're taking -3 for my x value here. So g of -3 is 2 times -3 squared plus 12 times -3 and then plus 19. So I have to, wherever there was an x, I put that -3, and I get my value of +1. This is my value for that. So if you think about this, we have this as my answer. By the way, that is the y value of the vertex. Just to explain that, this is the y value of the vertex. And if you wanted to write the vertex very simply, which we'll talk about later, is that -3, because we got the x value up here and this 1. So this is that vertex. But what answers you need are those ones in the boxes.